For those of you who were in George Fairbanks's presentation, he made fun of somebody who had like lots of 400 and something slides in their presentation. I have 409. So I think we should just get started. Hi, my name is Sebastian. Like Paul did such a great introduction that you probably don't need me to talk any more about myself. The agenda for today is we're going to talk a little bit about event sourcing. Then we're going to talk about event sourcing with CQRS, which is a separate pattern. We're going to throw in a little bit of DDD in there. And after we've done that, we'll talk a little bit about the upside and the downside. I don't want you to walk away thinking that this is, doesn't have any issues or problems or anything like that. This is a different view, a different pattern. But there are advantages and disadvantages with everything. It's not all sunshine and rainbows. I work for this company. Let's not talk too much about them other than to say that our history with event sourcing at Envato is the first system was put in production about 3 years ago. I was the lead on that project before I moved into my architecture role. From there, we kind of started extracting out a framework which we used when building the second generation of event source systems, which started coming into production about a year ago. There's probably about half a dozen of those, spanning a wide variety of business domains. And yeah, it used the first framework. We're now starting to look at the third generation of event-sourced applications. We're moving away from our framework, or we're not moving away from it, we're still using it heavily, but we're looking at other ways to do it, including a more functional approach as well, which I personally find very interesting. Let's talk about event sourcing. You heard event sourcing this morning, so I'll go quickly through what I think event sourcing is. Now, many systems out in the world log what they call events. But event logging of events is not the same as sourcing of events. I would say that most systems around today are kind of built around this database that stores the current state. And an event log kind of sits over on the side and just generating stuff. Event sourcing, on the other hand, forces the current state to be derived from all of the past history, all of the events. If you cannot reconstitute or derive your current state from your events, you are not doing event sourcing. What this means is, with event sourcing, all of your current state becomes disposable and becomes a cache. Did you say cache or cache? I always forget. You say cache. I say cache. It's probably the Swede or the Australian in me, I'm not sure. A cache can be deleted and regenerated, and that's the idea that event sourcing kind of promotes. I don't want to talk too much more about event sourcing without mentioning Greg Young. Greg Young is kind of, I guess, considered to be the father of event sourcing, or the person who has done a lot of work in bringing this pattern to popularity. Everything I'm about to say is either directly stolen from him or a bastardization of something that he's done. So lots of respect go to him. But he didn't invent event sourcing per se. In fact, event sourcing is not new at all. It's in fact a very old pattern that is at least 500 years old. Greg claims that he has been able to track event sourcing all the way back to ancient Mesopotamia. I'm not sure that that is necessarily true, but what I do know is true is that most mature industries in the world today already inherently use event sourcing. Finance, accounting, insurance, medical, legal, all of these industries that have been around for a long time are inherently event sourced. The canonical example, which we heard this morning as well, is the bank account, right? Your bank account balance is not simply a column in a current state database, right? It's not. Because Because what if you disagree with your bank and you say, I think I have $800 in my account, and they say, no, you have $500 in your account. Like the column says $500. That's not how it works. No. The balance of your bank account is actually an equation. And it looks like this. You take all of the transactions over the history of that account, all of the debits and the credits, the deposits and the withdrawals, and you sum them up. And that's how you get the balance. And you can manually calculate this. You can get a piece of paper out and you can calculate it. And event sourcing works exactly the same way. All current state is transient, the balance is transient, all current state is, and are the result of equations. This, by the way, is why a lot of people think event sourcing is a very functional concept. Functional goes very well with it, but it doesn't necessarily have to be functional. Your source of truth for your system becomes your event, not your current state, or any state at all. So what do I mean when I say events? Because this is one of the, in my opinion, one of the most overloaded terms that we have in the industry right now. In the context of this presentation, I want you to think of events as things that have happened that are of interest to you. They are business facts. And they tend to be expressed in past tense. They are something that have happened. So in a bank domain, we might have events that look like new account application received, customer identity verified, account opened, funds deposited, withdrawn, transferred, account statement issued, etc. In an e-commerce domain, like the one that I work in, we might have item added to shopping cart, item removed from shopping cart, order placed, payment received, goods dispatched, etc. In a calendar domain, and I like to talk about calendar domains because it's something that I think most people are very familiar with, you might have events such as appointment scheduled, appointment rescheduled, we've sent an invitation or we've extended an invitation for somebody to join our appointment, which can then be accepted, declined, we can cancel the appointment and so on and so forth. Events in this context are self-described. What I mean by that is that they completely describe the thing that has happened, and that's an important distinction, but that does not mean that they are denormalized, which is yet another important distinction. So the idea is that we want to try to keep our events focused on only the data for which they are the authoritative source. Like if I have my invitation extended event, then that might have a reference to the appointment and a reference to the person that I'm inviting and the reference of the person who's actually extending the invitation, but it doesn't have all of the denormalized data for all of those other things. So if we have a kind of more advanced example, which is the order placed event, that might have a reference to the customer that placed the order. It would probably have a timestamp. It would have a fully specified shipping address and billing address, assuming that we haven't modeled those as inherent different things in our system. It would have references to all of the items, all of the tax that was applied, any discounts, coupons, other adjustments that went into this particular order, as well as the total amount. And if we've modeled the payment as a separate thing, you would hold a reference to that as well. With event sourcing, these events become the very center of your domain, and modeling them is really very crucial. I'm not going to go into depth about how to kind of tease these out in this talk. There's one technique that we've been using, which is called event storming, and we're very, very fortunate to have Paul Rayner here at SATURN, who's giving a talk about this tomorrow. So if this is of interest to you, the whole concept of event sourcing, I highly recommend watching his talk on event storming, which is a way to figure out what your actual domain events look like. All right, so let's put all of this, what we know so far, into practice. If I have a shopping cart and I have a current state model, my shopping cart might look something like this. There would be some sort of cart object or model that would have a reference, or that would have a relationship to some line items, which are the items that are in the shopping cart, and as well as the shipping address and so on and so forth. This could be anything. This could be a couple of tables in a relational database. It could be a document in a document database. It could be an XML file. It could be anything. And we have often been taught that the shape of this data is the most important thing that we do. But this same data can actually also be expressed in events. And how we might do that is that we start out with an empty cart, and then we add an item to the cart, and then we add another item to the cart, and then we provide a shipping address. And using these 4 events, we can get this, right? We can build up this using these. But what we actually store is not this, but the events. These are the things that we persist into our database. And that's effectively what event sourcing is. It's just a different way of storing information, but one that has fundamental consequences. With event sourcing, and this is really, really key, all of your data is append only. What that means is that your data is immutable. You cannot change it after it has been written. Because it is immutable and it cannot change, it means that it can be cached and distributed forever. Which brings up the question of, okay, how do we deal with mistakes? If we write something that we shouldn't have, or if somebody, does something that they shouldn't have, or whatever it might be, how do we deal with that? Well, my counter question to that is, how does an accountant deal with a mistake? Let's say that they've attempted to transfer $1,000, or they wanted to transfer $1,000, but they fat-fingered the number and they transferred $10,000 instead. How do they do that? Do they, go into their ledgers and just scrub out the extra zero? No, they don't do that. They can't do that. What they do is they get the other person to then transfer back some money, and they correct. They create more data to correct the thing that wasn't quite right. And in event sourcing, we call these correction events. So we have an event that may not have been right, and then we add another event on top, which we call a correction event. It's the same thing with you as well. Let's say that you go to the ATM, and you say, I want to get $50 out, and you accidentally get $500 out. You have effectively 2 options at that point, right? You can't pretend like that withdrawal didn't happen, but what you can do is you can either say, well, and put $500 in your wallet. You can accept the mistake that happened, or you can, assuming that the ATM supports it, you can take $450 and just put it back into your account. Now that will look like a withdrawal and then a deposit. And that's exactly how event sourcing works as well. In a shopping cart, we might go and say, a person goes and adds an item and then adds another item, and then actually I didn't want that item, so I'm going to remove that from my shopping cart. And what we end up with is a current state that doesn't include that item that was removed. Here's my question for you. Are these 2 things the same thing? No, maybe. The current state that's derived from this would be the same, right? In one case, yeah, it would be the same. So let me give you a challenge and say, can you think of something similar to this in your application, in your system, where you have 2 use cases, completely separate things, or 2 different things that can happen that would result in the same current state? It's more a rhetorical question. If you can, then you are losing data. So my follow-up question to you then is, how do you determine which data you're happy to lose? And if you know the answer to this question, then come talk to me afterwards, because I really want to find out, because I have never been able to figure out which data we can just drop on the floor. I only have one rule that I'm so reluctant to break, and that is never lose data. Because I don't know how to value data. I don't get to sit with the CEO every single time we build anything and say, hey, what's the value of this data, and is it okay if we delete it? In most cases he would say, no, absolutely, don't do that. But we do it anyway. And even if we don't know even if we can figure out what the value of this data is right now, we can't predict the future value of this data. So why are we throwing it away? This to me is the main benefit of event sourcing. You're never losing anything. Going back to our shopping cart again, this will happen, right? The CEO will come and say, you know what? I think we have a great marketing opportunity here. We can, people that have added all this stuff to the shopping cart, but then they got all the way to the end and then they removed it, they were probably interested in that. So let's see if we can't, send them a follow-up email or something like that to see if they will come back and buy that thing. And if we had a current state model, what we would do is we would say, yeah, absolutely cool, let's do that. We'll introduce another table in our relational database, and we'll start capturing all the things that people have removed from their shopping cart, and if you come back in 3 months, then we'll have some data for you. The CEO says, cool, awesome, 3 months from now, that sounds great. But if I have an event-sourced model, I'll say, oh yeah, okay, yeah, we can just look at all the item removed from the cart events, and we haven't really looked at it in this particular way before, but we'll just write up a projection. We'll talk more about what projections are later, but we'll write up a projection. We will have to go all the way back from the beginning of time, and it might take a little time. Maybe it takes a weekend. I don't know. But that's okay. It's asynchronous. Come back next week, and we'll have this data for you. I think the CEO is slightly more happy in the second scenario. In this approach with event sourcing, we're not losing data, and the benefit of that is that over time we will come up with new and interesting ways to interpret the data that we have. There was I think a talk yesterday that said we don't have a time machine. I have a time machine. If I want to know what a particular report looked like exactly a year ago, I think that's actually pretty much spot on. I thought I'd get to here about 16 minutes past. How am I doing? Yeah, okay, cool. If I want to know what something looked like at a particular point in time, that's cool, I can get that. I only replay the events up until that point in time. What does that mean? It means my system is now deterministic. I can get back to the state of my system at any point in time, ever. It's easy to go back to, we had a bug that was, that happened because of the state that was going on at the time. We can easily do that. I know what you're probably thinking. You're saying, sure, sounds great. That can't scale. If we have a lot of events, hundreds of thousands, millions, tens of millions, hundreds of millions, billions, etc., right? This can't work. And this is now where we start talking about event sourcing in CQRS. So what I wanna do is mention CQRS, which is another pattern. It's called Command Query Responsibility Segregation. It was also popularized by Greg Young. And what it effectively means is we want to try to separate our reads and writes. And the important thing that I want to mention here is it's very possible to use event sourcing without CQRS. It's also possible to use CQRS without event sourcing, and I think that if you take anything away from this should be it. You can use the fundamental concepts of event sourcing without any of the rest of the presentation effectively. It's just that the two of them go really, really well together. There are 4 major building blocks to the architecture that I'm going to try to describe to you today. The first one is the event store. Then we're going to use queries to read and commands to write. And then we're going to talk about something which we call reactors, but I don't know that there is a canonical name for. So, what's the event store? And I think this was mentioned in a couple of different presentations. I think Chris may have mentioned it this morning. What's an event store? Well, the event store is effectively a database that keeps all of the events. And it's kind of more than a database. In many cases, it's almost considered a subsystem in its own right. There are several commercial and open source options available for fetching or using an event store, but it's easy enough to roll your own. We did. The simplest event store has a single event stream. So if you were in George Fairbanks's talk earlier today, he was talking about having lots of different event streams, and events are being mapped between different streams and so on and so forth, and that's absolutely possible, and it's possible to do with this paradigm as well. But for the sake of trying to keep things simple, let's just consider that we have a single event stream which all of the events occur on. And the simplest event store only has 3 features. That is the ability to put an event into the event store, the ability to get all of the events in order, starting from a particular offset. Their offset might be 0, in which case you start from the very beginning. And the third one is get all of the events in order, scoped by something, and we'll talk about what that something is. So you're effectively getting a subset of events. And these are the 3 features that we will be making use of as we build out this architecture. So let's start with reading, because reading is almost always easier than writing. I'm 20 minutes in and I'm already on slide 98. So far I'm doing pretty well with time, I think. Clients need to read information. I don't think that's a controversial statement. A client in this particular case could be a browser, it could be another application. It's something that is interested in reading data. Clients are usually interested in the current state. Sometimes they might be interested in history, but usually they're interested in current state. And one thing that we found is that the event store itself is not very suitable for presenting current state. So we need something else that the clients can query for current state. We call this a query handler, which means that we kind of take a little bit of a detour here. Rather than going directly to the event store, the client goes to the query handler, and the query handler does something with the event store. Well, what the query handler does is it tails. It processes, it subscribes to the event stream that the event store provides. And as it does that, it builds up a projection. And we talked about this earlier, and Chris mentioned it earlier this morning as well. And when the client wants to know something, the query handler uses the projection instead. So the projection is effectively a current state representation that's sourced from the events. So yeah, the query handler returns the data back to the client from the projection itself, not from the events. And there are going to be many projections in any given system, and they tend to be optimized for a particular query. I like to think that you might have a separate projection for every single screen in your application or for every single endpoint in your API. Which means that when the client gives or asks the query handler for some information, it will say, oh, that information is over here. In this projection, I'm going to pull that out and give it back. The projections are kind of built up separately and individually. And we have these other processes that we call projectors. It's I think, a pretty straightforward idea. You have a projector, which is a process. That's the thing that processes the event stream, and it builds up the projection. I want to point out that this is not using the observer pattern at all, which is often a common idea. Because what we're actually doing is we are getting all of the events in order from an offset. This is this event store feature that we're using in the projectors. Each of the projectors keep a pointer or a bookmark or an idea of where in the event stream that they're at. So they keep reading events from the event store, understanding where they are in the stream. They keep track of that. It's their responsibility. It's not the event store's responsibility to know where individual projectors are up to. The projections are disposable, and the only, how we deal with that is, we ask that the projector, we reset that pointer or that bookmark to 0, and then we go again. What this means, because these are independently running processes, it means that they are completely decoupled from each other. They can be in different points in the event stream. And as Chris mentioned earlier this morning, this allows us to have different technologies if we want to for our different projections. So pick something that works for you. If you want to have a relational database or a search engine, or hell, even if you want to write CSV files or PDFs or something like that and have that be your projection, that's totally fine as well. The point of all of this is we can really optimize for how we want to read the data. The current state read models that we tend to find in MVC applications and so on and so forth tend to be normalized, which I take to be that they are optimized for writing data. Our projections can be, and most often are, completely denormalized, which means that they're optimized for how we want to read them. They're really cheap. The only thing that they cost is effectively another process that sits and reads from an event store that builds up a database table of some form. Database tables tend to be pretty cheap. I mean, data storage is getting cheaper and cheaper. So they're pretty cheap, and they're easy to spin up. If you have you want to maybe change one of these, the way that you do that is not by going in and messing around with the current projector and the current projection. You just create a new one. And when you do that, and it might take a little bit of time for it to build up and rebuild up the new projection, but once it has, you can just hot swap. Did you see the arrows moving there? You can just hot swap to the new projection and have the query handler starting to read from the new projection, at which point you can just ditch the old ones. Delete the code, delete the table. This means that you don't have to do any more database migrations on any production tables ever again, in theory. We never have. We never have. It's a new projection every single time, and they don't take that long. So, summary, reading with queries. Oh, software changes are required. My IT department, it's not my laptop. Anyway, clients never query the event store itself. Instead, they query denormalized projections that are optimized for the job itself. These projections are built up with projectors that process the event stream. Projectors are decoupled from each other, and they don't share any state at all. They are cheap and easy to rebuild. That's what we just kind of talked about. And this is how we read data in an event source system, well, event sourced in CQRS. So let's talk about the other side, writing. So clients frequently do not only want to read information, they also want to write. I think that that's okay. They should be able to do that. Before we said that the client shouldn't be reading directly from the event store, and in this particular case, we don't want the clients to be able to write directly to the event store either. That's because the event store is not responsible for validations, and so if we try to give clients direct access to it, that would be kind of dangerous. It would kind of be like opening your SQL database directly to the world. So let's not do that. Instead, what we want is we want clients to express their intentions via something that we call commands. And commands represent intent. And I have more than one slide on this. I found out a little too late. And just like we had something responsible for handling queries, it makes sense that we also need something that is responsible for handling commands. And I'm pretty sure you can guess what that's called. We have a command handler. Just said that. So, if we look at events and command naming, we said before that events were expressed in past tense. Account opened, funds deposited, funds withdrawn, funds transferred, account statement issued. Then the command version of those things, of those events, are expressed in the imperative. So open account, deposit funds, withdraw funds, transfer funds, issue account statement. These, on the right-hand side, they are expressions of intent. They are something that we want to do, whereas the events are things that have happened. And that is really, really key. Commands can be rejected. We can say, no, you're not allowed to do that. Events, on the other hand, they're fact, they're something that has happened. They can't be rejected because they have happened. A command that is accepted, on the other hand, results in an event. So, how does the command handler validate commands? And this is where we start borrowing from DDD, just a little bit. We're not doing all of DDD, we're doing just a little bit. I should mention before I talk about that DDD doesn't really come into play on the query side, in the query handler, but it definitely does on the command side in the command handler. Because here's the thing, we think that events happen to something, that they belong to something. And that something is what we call an aggregate. And an aggregate is a DDD term. And I think Chris mentioned this in his presentation this morning as well, which is really, really good because he's kind of like laying the foundation for all of this. The aggregates are the nouns in our system. So you're probably used to having nouns in your model names and so on and so forth. So if we go back to some of these bank domain events again, we can start mapping out what the aggregates for these domains or for these events would be. So the new account application received would probably happen on an account application aggregate. The customer identity verified would probably happen on the customer aggregate. The account opened, funds deposited and withdrawn would probably happen on an account aggregate, maybe. Funds transferred, we'd probably want that in a separate transfer aggregate that references other account aggregates. And the account statement could be its own aggregate as well. In an e-commerce domain, some of the aggregates that we might see might be customer, shopping cart, order, payment, product or item, shipment. In our calendar domain, it would be calendar, appointment, invitation, etc. Aggregates have identity that we need to track over time, and they often have life cycles. And they can refer to each other. So, for example, the order aggregate would probably have a reference to the customer aggregate. So when a command is received in the command handler, what we want to try to do is we want to try to execute this command against the aggregate. And in order for us to do, and then the aggregate itself determines whether we can accept or reject this. And in order to do that, it needs to know its current state. We're not saying that we don't, like current state is useless. No. Current state is very, very important. The whole idea about event sourcing is how you get that state. So it's going to be a few slides with a little bit of code to try to explain how this works. It's more pseudocode than anything, so don't read too much into my awesome coding skills. We start by loading all of the events for a particular aggregate from the event store. That's how we begin. We get a command and we load all of the events for the particular aggregate. We then create a brand new aggregate class, like a brand new instance of this aggregate. At that point, it's empty. It doesn't have anything, no identity, no nothing. And then we go and we tell the aggregate and say, hey, here are all the events that have happened to you. Go and replay them. And once we've done that, we attempt to process the command against the aggregate, which will usually return a true or a false. Can also have validation errors and so on and so forth, but let's not go too deep into that. So let's say that we want to withdraw some funds. We have a command. The command has an account ID and an amount. That's it. We start by loading all of the events for this particular account. What we get back are three events: a funds deposited, another funds deposited, and a funds withdrawn. And then we create a brand new instance of an account object, or an account aggregate, and we ask the account to replay all of these events. Now, inside the account, we have this function method called replay events. All it does is it iterates over the events. These are ordered, and applies each one, which means that it needs to have an understanding of how each individual event changes it and impacts it. So in this particular case, whenever it applies a funds deposited event, it adds to the balance, and the balance is the current state. And when it gets a funds withdrawn, it just removes that amount from the balance. So at this point here, the account has a balance, which means that when we go to withdraw, we, which is the command itself, we just see if the amount is greater than the balance, sorry, you can't do that, and we return false. If it isn't, if we have the funds, then we issue another event of the fund withdrawn type of the amount that we just withdrew and return true. So what we're doing here on the aggregate side in the command handler is we get all of the events in order scoped by something, and then we put events. And now that we've gone through this exercise, we know what the something is, and that's the aggregate ID. These are the three methods that the event store needs to support. Obvious question, isn't this slow? Sure, if your bank account balance has 3 events, it probably won't be very slow. What if it has 300, 3,000, 30,000? And yeah, absolutely, it can be. Something that you want to try to do is keep the number of events per aggregate low. This is a really, really important aspect of trying to get this right. I think that an account that accumulates an unbounded number of events over time is a smell. Like, for instance, before I go into that, wherever possible, have fixed life aggregates. So we wouldn't put order placed events onto the customer aggregate, because every single time a customer would place another order, it would, just continue to accumulate events on the customer aggregate. So instead, we build up a separate order aggregate that references the customer, and the order aggregate has fixed life, right? You place the order gets shipped, you generate an invoice, and at some point it closes. It has a finite life, it has a life cycle, and that's kind of what we want to try to get out of all of this. Having said that, domain modeling is hard, and event sourcing doesn't change that. It doesn't give you any shortcuts or anything. I still lie awake at night on aggregate modeling decisions that I made 4 years ago, saying, oh damn, we should have done this, that's always going to happen. But if you screw it up, like I have done, and you find yourself with too many events per aggregate, there is another tool that you can use, and I think that this has been mentioned once or twice as well. It's called snapshots. Snapshots is effectively the memento pattern from the Gang of Four book, if you're familiar with that. So the idea is that if we have, let's consider all of these events as events that happen on a particular aggregate, what we can do is we can say for every 100 events, we want to take a snapshot of the state of that aggregate at that particular time. It's not a current state cache. It's not about the current state. It's about the state at this particular point in the event stream, which means that the command handler can load the snapshot and then the most recent snapshot and then only load the events that have happened after that point. So we're not trying to keep every single current state of every single aggregate, but we can say, you know, every so often we just take a snapshot. But it's also worth pointing out that snapshots are a purely technical optimization and doesn't play any role whatsoever in the conceptual model of event sourcing. So, you know, most event source systems that I've been involved with have had nothing to do with snapshots because we haven't needed them. All right, summary, writing with commands. We never want to write directly to the event store. Instead, we want to be able to express our intentions with commands. Commands are validated by aggregates, which is a borrowed concept from DDD. Aggregates, they fetch events from the event store and replay them to reconstitute their current state. If the aggregate accepts the command, it results in an event. And if replaying events get slow, we can improve performance with snapshots. Sorry? Yes?
So the commands don't operate on top of a projection because you want to avoid stale data?
Correct. Yes. Sorry, it took me a moment to... yes, and we'll talk a little bit more about why that is later. So, where does all of this leave us? Like, where are we at in our architecture right now? Well, we have what we call the circular architecture, which means that we have a client who are, you know, interacting with the command handler on one side and a query handler on the other side, and both of them interact with an event store. Obviously, the command handler is on the right side because right, no, never mind. And how this works is clients express their intents through commands, which, if they're accepted, they result in events. Projectors living in the query handler side of things, they process the event stream and build up projections. And then the clients retrieve data from the projections via queries. This is the effective architecture that we're working with. What this means is that reads and writes, queries and commands are decoupled from each other, which is kind of nice because it means that we can scale them independently. It's great if you read heavy. We are. I think we're 99.6% reads versus writes. I call that being read heavy. And this is kind of a crazy diagram, but it kind of expresses the idea that you can have a single event store and a single command handler and then replicate your read sides. You can put them in different regions. If you're using AWS or something like that, you can actually have geographically distributed read sides. They have their own projections, which means that even if the middle part goes down, you can still read data just fine. It's great for availability. It's great for scalability. It's horizontal. Writes are usually fast and always consistent. This kind of goes back to Paolo's question earlier, because they're always, whenever you're trying to do a command, it loads all of the events relevant to that command and tries it. Reads are fast, but they are eventually consistent. And we'll talk much more about eventual consistency later in this talk. Because before we do that, we have the fourth major building block that we want to talk about, which are reactors. So if commands are for client writes and queries are for client reads, then reactors is for all the stuff in the middle. In order to explain this, we have to extend the circular architecture a little bit. Reactors, they process the event stream just like projectors do, but they don't maintain projections that people can query. Well, they also have a pointer of where they are, just like projectors. In fact, you can argue that a projector is a type of reactor, but it's probably not a distinction worth making right now. But instead of building projections, what they do is they react. They take some form of action to the events that they see. That could be through triggering some external behavior, or by emitting new events back into the event store, or both. So let's get a couple of examples. Let's say that we have a reactor that sits and it's processing and it's subscribing to all of the order-placed events that we have happening in the event stream. At some point, it detects that a particular customer has now placed a 10th order or a 100th order or whatever the business rules say, at which point it's the reactor's job, and it's its only mission in life, to emit another event back into the event stream saying, this customer is now considered gold class, or however you want to think of it. This reactor is stateful. It's because it needs to kind of keep track of how many orders each individual customer has placed. And many reactors do have some sort of state. If they do, then we call it reference data, and sometimes we call it internal projections as well. What it effectively does is it just watches the stream of events coming past, and then when something that triggers its business rules happen, it reacts. Let's give another example of how a reactor can also undertake asynchronous side effects that logically follow from an event. So, we might have another reactor. This is a completely separate one to the one that we just described, that now subscribes to the customer promoted to gold class event. And this reactor is the welcome email reactor. So what it does is it sends an email to the customer saying, hey, welcome, you're now gold class, and here are all the benefits, and so on and so forth. And after it's done that, it emits an event back into the event store saying, I've just done this. I've just sent the gold class welcome email to this particular customer. Effectively, it executes the side effects that happen from us declaring that this customer is now gold class, and then it emits an event to that effect. When building these slides, I'm going, if that's the only responsibility that this thing has, is it really a side effect? I don't know, but let's skip that for the moment. What matters is that we get a full audit trail of every single action that the system has undertaken. We've seen a little bunch of orders, we've promoted a customer to gold class when we hit a particular set of business rules, and then we've sent them an email. And all of those things are captured as events. Reactors use the two following methods of the event store. It gets all of the events in order from a particular offset, just like the projectors did, but it also puts events back into the event store, just like the command handler did as well. Just like projectors, reactors are decoupled from each other. They run as single-threaded processes. Like projectors, reactors are asynchronous and subject to eventual consistency, which again we'll talk more about. Reactors typically do not share any code. They absolutely do not share states, except and they don't share their internal projections, nor do they ever access any of the external projections that, the ones that we build up with projectors that the clients use. So they are completely isolated and self-sufficient. If a reactor needs state, it's responsible for managing that state itself. There are sometimes exceptions with things like canonical views, but you have to be really careful about temporal coupling. And the idea is that these reactors should be built so that they can be deleted or lost, go down for a period of time with no loss of system integrity except, something, we might not be sending welcome emails for a while. Reactors kind of behave a lot like microservices. So if we want to be buzzword compliant, then this is kind of where that aspect comes in. Reactors approach idempotence. It's very, very difficult. I don't know how to do it myself to make them fully idempotent. But for the most part, reactors will not re-trigger external behavior when they are rebuilt against going back all the way from zero. And that's really important. That's an effectively built-in feature. They're not 100% idempotent because there are some edge cases where interesting things will happen. But for the most part, they approach idempotence, which means that we can reset them back to zero if we want to as well, and just start from the beginning. Reactors do one thing well, and they really encourage a business-oriented decomposition of the system rather than a technical one. So we can slice by capability. And going back to something that Chris mentioned earlier, sagas are typically built up by a series of reactors. So you might have the gold class customer saga, which consists of these reactors that we've talked about, but also other ones. Sometimes we also talk about sagas as process managers. Sagas, in and of itself, has kind of weird connotations in the software development industry. Not sure. I think reactors are really freaking cool. They're, to me, one of the most awesome and beneficial parts of this entire architecture, but they are also where you tend to find most of the complexity, whether that's the necessary inherent business complexity of your domain or accidental complexity. So, summary, reactors. Reactors process the event stream just like projectors. They react to events in several ways. They can react by raising new events at a different level of abstraction. They can trigger side effects that logically follow from an event. They leave an audit trail in the form of events. They are decoupled from each other and they do not share any states. And they create the foundation for implementing sagas. Oh, there's one more. Reactors, are often a source of necessary or accidental complexity. All right. So this is more for me than for you. I think we're doing okay with time. We've got about 35 minutes left by my watch. Yep. Is there a question?
Situations have you used reactors to create your projections instead of the projectors pulling the projections?
Never. I think the question was, have we ever used reactors to build up projections rather than having projectors tailing the stream? And no, we've never done that. If you want to talk more about that afterwards, then I'd love to do that. All right. Quick recap. Event sourcing with CQRS. Event sourcing makes you store business facts as the source of truth. Event sourcing makes the system deterministic. CQRS and the circular architecture that we have works really well with event sourcing. Clients express intent with commands, which, if are accepted, become events. Asynchronous projectors process the event stream and build up denormalized projections, which is what the clients query whenever they want to know something. We then have asynchronous reactors processing the event stream and reacting to events according to whatever business logic that they have, and that usually results in more events. Let's talk about why all of this is good. So this is the list of why I think this is cool, why I think this is good. The first one being, it treats the core of your business with respect. I don't think that there's any more respect that you can, you can't place any more respect on your data than by placing it at the very core of your system and then never ever changing it. we're not losing data that we can't value. Like if we don't know how to value our data, the least we can do is make sure that we're not losing it. We can't predict the future, and this allows safeguards for being able to do things in the future with the data that we have. I just said that. Events, to me, they represent fundamental business happenings that always have been and always will remain of fundamental interest to the business. So we are kind of, we'll talk more about this later, but we're really treating business concepts and business events and happenings, facts, as the very core of our systems. Event sourcing is very compatible with reality. It borrows a lot from the real world, because just like in the real world, time is a first-class citizen, and this is not something that we see in a lot of systems these days. In the real world, the past is done. You can't unchange something that happened. I decided to get on a plane and come to Denver, right? That's not something that I can undo. The only thing that we can do with something that's happened if we don't like it is to compensate for it. And event sourcing works exactly the same way. The real world as well, and we'll talk more about this. In case you're wondering, the eventual consistency bit is all in the downsides part. But the real world is also eventually consistent because there is no central control. And it's the same thing here. The real world is made up with independent actors that do the best with the information that they have. And that's how our reactors and projectors work as well. Yes, they are eventually consistent, but they do the best with the information that they have. The real world also doesn't have distributed transactions across autonomous agents to keep things in sync, and neither do we. And there is no evidence that in the real world this is a problem. And in event source systems, we don't assume that there is one either. In the real world, core concepts change very, very slowly, as do they in event source systems, while instead we kind of frantically innovate at the edges. Event sourcing, surrounded by lots of disposable and replaceable interpretation of what's happening, is just like that. The events, the core, change slowly, but the interpretations and the experiments around it happen quicker. And so you've got your hand up. Can I ask you a question at the end of the session? Is that okay? Great. With event sourcing, we seek to emulate the real world, and whenever we encounter problems, one of the first things that we do is try to understand, okay, how would we model this in a paper world, right, where we don't have databases or anything like that. If we only were shuffling around papers, how would we deal with it? Event sourcing, I think, also really allows rapid interpretation, iteration and reinterpretation. Because here's the thing, right? We've been kind of brought to this idea that we live in this very quick evolving world where things change very, very rapidly. And I don't actually think that that's true. I think that there are key concepts in every business models that are quite stable. Customers, suppliers, contracts, product, these things tend not to evolve all that quickly. And it's the same thing in this. If designed well by designers with understanding of the business domain, is kind of like the disclaimer, the asterisk there. The rate of change for events is low. But meanwhile, we can separate the recording of what happened from interpreting what that means. Which means that our interpretation and experiments are really easy to build up and then easy to get rid of when they're no longer needed. Even experiments that create events can be discarded just by ignoring those events. I think that event sourcing also promotes good practices. We get separation of concerns through isolated asynchronous components. If a reactor or a projector breaks down, it only really affects itself. When it comes back online, like it just picks up where it left off. New features tend to involve extending code rather than changing it. So, you know, you need a new capability, you go and you create a new reactor, or you create a new projection, or you create a new command handler, or whatever it might be. One of the main benefits for me as well is that this kind of encourages code that are expressed in business and user terms. We can remove abstractions and form better ubiquitous languages, and I think this is really, really important. It's interesting that in my work, the people who are most, the biggest proponents of event sourcing is not technical people, they are the business people. Because they can very easily reason about how a system works, because they think in terms of events. The models that we build up tend to be abstractions on business events, but the business folks tend to think, in my experience at least, in terms of events. And this is a way for them to express how, you know, to have systems that reflect their understanding of how something works. We get nice unidirectional coupling, which I think is a good benefit. And it provides logical seams for microservices. So, you know, big question is, how do we build microservices? In this particular case, we slice by business capability, business rules, etc. Event sourcing in this particular style of architecture, I think, has some good quality attribute support. Eventual consistency in and of itself, while it has downsides, I think is more scalable and available than approaches that mandate strong consistency. Reads, we talked about this earlier, reads can scale horizontally and achieve high availability through geographical distribution and so on and so forth, while writes can still be very fast while still remain single-threaded, which is cool, and all of the benefits of, you know, running single-threaded code. For the integrity miner, this is pretty cool. You can use worm media. How many people have heard of worm media before? It's short for write once, read many media. Think CD-ROMs, right? You can write data to a CD-ROM once, but then you can read it back many times. If you really care about the security and the integrity of your data and you want to make sure that it can't be tampered with, you can use worm media for all your events because they're append-only and immutable. And obviously, append-only data that captures facts provide really good auditability, and we can get a really good sense for everything that our system has ever done. This style of architecture, I think, avoids a lot of common pain points. Database migrations, we covered that earlier. ORMs, there's not an ORM in sight for any of this. We kind of avoid the tightly coupled lazy loaded object graphs that are really hard to understand and reason about. And it also lets us use the best tool for the job. So, you know, we were talking about how different, you know, we can use different databases. We can even build reactors and projectors and so on and so forth in different languages if we wanted to, if we needed a particular feature from, I don't know, Haskell or something, I don't know. And write data storage as well. Obviously, there's an operational cost associated with all of this. And I'm not trying to make that seem irrelevant. It isn't. You obviously don't want to run 20, 50 different databases if you can help it. It also works well with, as your systems and your teams grow larger, you can have different teams be responsible for the reading and the writing of the data. You can have teams that are responsible for a specific set of reactors, etc. And another aspect as well, which I'm not going to go into in depth, but it is very possible to use event sourcing for part of your system. So if you have a current state application and you want to you know, only make this core concept event source, then that is absolutely possible. You might not do it exactly the way that we've described it here, but the concept of event sourcing should be is definitely workable. You get a free time machine. We've already talked about this, so I won't go through that in detail. So, what are the downsides? This is the list. Eventual consistency is first. Let's dig into it. We talked before that, commands are synchronous, right? We send a command, it gets immediately evaluated, and if it's successful, it puts an event into the event store. And that's a synchronous operation. The client gets immediate feedback of whether that was successful or not via effectively an ACK or a NACK. Queries are also synchronous. So you issue a query to the query handler, it will load whatever data it's got in its projection and immediately return that. That's synchronous. Projectors are not synchronous. Projectors are asynchronous. So, an event, it's pushed into the event store, and then because the projector is working off that asynchronously, whoa, that was a bit too quick. There we go. It can take some time for changes that we have written via a command to show up on the read side in projections. And that is shit. I totally spoiled that slide. And here's the thing. Reactors are asynchronous as well. Like inherently, they use the same mechanism of tailing the event log asynchronously, which is also shit. And to add more icing on this cake, because projectors and reactors are autonomous and decoupled from each other, they can be at different points in the event stream, which means that a change might show up in this projection over here, but it's not in this projection over here just yet, which is triple shit, right? When not all parts of a system has the same idea what the current state is, this is what we call eventual consistency. Thing though is the real world is eventually consistent as well. Because as we talked about before, independent actors can act without consulting each other. And I'm going to use a couple of examples here, which might be stretching things a little bit, but to give you a sense for how eventual consistency works. Let's imagine that your car's getting stolen. Like while you are sitting in here, listening to me, your car outside is getting stolen. You don't know this, right? Because your copy of the world is not in lockstep with the world out there. In your copy of the world, your car is exactly where you left it. But hours from now, when you walk out of here and said, that event sourcing talk, that was really good or bad, depends on what you think. You find out, where's my car? My car's gone, right? That's when your copy of the world is made consistent with the world out there. And this is eventual consistency. Another example, let's say that you've applied for a bank loan, and right as we're sitting here or later this evening or something, the loan manager at the bank rubber stamps it and says, yes, you're getting the money to buy that new house or car or whatever it might be for. And then this evening you phone up your partner and you talk about, do you think we're going to get the loan approved, or when do you think they're going to let us? Not realizing that this loan has already been approved, right? A couple of days from now, you get a letter in the mail informing you that your loan application has been approved, and that's when your copy of the world is being made consistent with the bank's copy of the world, right? And this, again, is eventual consistency. This is how the world works. If you look for eventual consistency, you will find it everywhere, right? the light from the sun takes 8 minutes to get to the Earth, which means that the sun could have vanished 6 minutes ago and we wouldn't know it. It'll take 2 more minutes before our world, before our copy of the universe becomes, is made consistent with the rest of the world. Modeling systems with all these lessons that we've learned from the real world is very helpful when dealing with eventual consistency. But we, as the almighty software architects, software developers, we're better than this, right? With software, we can push the natural boundaries of the world, can't we? It's a trick question, because your system, whether you know it or not, is already eventually consistent. As soon as you let go of a database connection, you have no way of knowing whether the data you drew from it is still correct. It's entirely possible that while you are formatting the HTML to return back to the browser, the data itself might have changed. That's what I just said. You can narrow this time window as much as possible, but you can never fully eliminate it. And if you can't eliminate it, all you can do is manage it. And what it comes down to with eventual consistency is that risk is a function of time. I often ask people, how many people think that a nanosecond of eventual consistency is okay? Few people at least? Yeah. I would say that most people think that a nanosecond of eventual consistency is totally fine. How many people would say that a month of eventual consistency is fine? Very, very few people, right? That's great. It means that at some point between 1 nanosecond and 1 month is your threshold for how much eventual consistency you are willing to accept. And this threshold is contextual. If we're showing the order status to a user, we might say a second or 2, that's our threshold. We want to make sure that the data is consistent within that amount of time. But if we're looking at a sales report for last month, or this month even, maybe the threshold here is hours. Maybe. And this is because all of this is a business risk, not a technical risk. And what we want to ask ourselves is, what's the risk of making decisions with out-of-date information? If we're looking at a sales report that's a few hours out of date, we're not going to necessarily make bad decisions as a result of that report. A user who's looking at their order, on the other hand, they might decide, oh shit, I don't see my order here, I must place it again. Right? That is an example of a bad decision made with out-of-date information. So that's why that threshold is lower. The thing with event sourcing and CQRS, though, is even though you all have eventual consistency in your systems, this makes it a first-class concern. It emphasizes eventual consistency. It's a feature, right? And this represents a hell of a lot of challenges, especially for developers that are not used to dealing with this. Even though it's always been there, if people haven't been dealing with this, it is a significant mental barrier. Now, there are ways of managing eventual consistency. I'm going to mention a few of them. The first one is to educate your users, right? Set expectations. If you've ever unsubscribed from a newsletter and the response that you got was, please allow for 7 days for this change to take effect, that's eventual consistency in action, and you've just been educated. You've just had an expectation set that it can take up to seven days for it to take effect. What if your UI could say, hey, thanks for submitting an order, please allow for a couple of minutes before you get your email, and all this sort of stuff. Second thing that you can do is you can lie to your users. You might not think that this is very nice, but let me explain how it works. Basically, what you want to try to do is as you are writing some data, you have that data there, right? So the user that's placing the order, in that process, in that whatever it is, in that browser, for instance, you have all the order details. And as soon as you get that ACK back from the command handler, you know that that's been successful. Now you can display that order back to that user, even though it hasn't made it all the way around to its production, but you can just kind of hold on to that data. So you're kind of not being entirely truthful because you kind of, the data hasn't been made consistent with everything else yet. And if any other user tried to look at that, it wouldn't be there. We also call this read your own writes. So if you're writing some data, you can keep that cached at the same time. The next thing you can do is you can build new interfaces, and this kind of goes hand in hand with educating the users. Like if you have user interfaces that as soon as you create something, you immediately go to that, well, you can decide to do something else instead to better account for all of this. Next thing you can do is slow down the user. This is literally why spinners were invented. And you can speed up the backend. That's also a very valid pattern. Now, none of these are going to be appropriate for every single eventual consistency problem. But somewhere in here, a combination of these things will help you manage it. But even though it is manageable, this can be an absolute blocker for a lot of people. So don't underestimate the complexity and the danger and the challenges that come with placing eventual consistency as a top-level concern. Let's talk about handing over the crown jewels. This will probably go, I hope this will resonate for a lot of architects, because I think that there is nothing more important to us than the data that we store in any business. There was a workshop earlier in the week with a quote from, was it Harold? And he said that apps age like fish and data age like old wine, or data age like wine, which I kind of like. I like the idea of, data persists even when technology doesn't. Like we have companies that have been in business for hundreds of years. They will have gone through many different technology, like they'll have filing cabinets, they'll have had COBOL systems, they'll have, maybe now they use Java or something like that. They will have gone through many different incarnations of their technology, but their data has persisted all throughout that time, unless, they've had fires of some, anyway, you kind of get the idea. If you're going to undertake something like event sourcing, what you're actually doing is you're fundamentally changing how you store the core of your business data, and that is a risk. And if somebody asks me, as the architect, can we just fundamentally change the way that we store all of this really important business data, my default answer to that is going to be no. Opacity. I really like that Chris mentioned this as well in his keynote this morning. It becomes harder with an event source model to go and poke around and try to answer questions, right? If I join a team, if I join a new company, there's a lot that I can gain simply from being able to go and read the relational database that they have. I can't answer every question, but I can answer a lot, and I can gain an understanding of the business. With event sourcing, that isn't really possible. And it's not just developers that need to be able to do this. Like, we have a lot of people in our company that have SQL experience that aren't developers. The fraud team, for instance, and all of these other teams, business analysts, etc. They rely on this data, and if they can't easily query it like they can with this SQL database, then that makes things harder. Because an event store renders all of these tools and the ubiquitous access to it is irrelevant, and this can be a big deal in a company. Your data is more opaque in an event store, and there's no way around that. You have to create projections in order to make sense of it, but that's effort. At the same time as, you can't easily read it, you can't easily fix it either. Like if you make some mistakes here or there or whatever it might be, you can't just easily go in and change a column. And this is both a feature and a bug, both an advantage and a disadvantage, right? It's part of the fundamental concept of event sourcing is you can't change anything, but there are times that that's really, really handy as well. Thanks. I should be good on time actually. Yeah. Mistakes are forever in an event sourced world. And here's the thing, like the schemas of our events, they will naturally evolve. But we can't change events after the fact. So things like upcasting, like taking the schema of an old event and then transforming that to the most recent schema of an event, they become norms. Creating compensating events become norms. Confidentiality can also be an issue. Imagine that you are writing sensitive PII data, social security numbers, or anything like that directly into your events, and you're writing that to write ones, read many media, or whatever it might be. You can't change them. They might be automatically distributable, etc., etc. You have an issue. You can't go back and scrub. There are obviously strategies for how to deal with all of these. I'm not going to go into them in details, but come find me afterwards if you're interested in the 4 ways to deal with event evolution. But some of them can be quite painful, and the very last one of those 4 I call the nuclear option, and it's certainly not for the faint of heart. Event sourcing is not mainstream. I don't think that there are enough resources. There aren't enough books, courses, presentations. There aren't enough libraries. There aren't enough frameworks, and there may never be. It's not in the mainstream, and that creates a barrier of adoption. It can be difficult to hire people that know how to do this. And in my experience, many teams with little prior knowledge to this is going to struggle really hard. You almost have to have somebody who's done it before. It's not entirely true, but I think it's certainly an issue. I also want to talk about the J-curve productivity. The J-curve looks something like this. I do think that once you get over to this part of the curve, the cost of change actually remains lower for a longer period of time, but that initial part can be a barrier for many businesses. You are going to slow down delivery, particularly for your first few systems that you build with this paradigm. It will get worse before it gets better. It's effectively the reality. And it takes time before all of these benefits kick in. This is particularly true if the choice was made for the team and not by the team. And I would never try to impose event sourcing on a team that don't have buy-in to try it, that don't have the stakeholder support to try it, or who lack what I call the intestinal fortitude of, doing it. Complexity is also an issue. But before we talk about that, I want to say that we don't want to conflate the inherent necessary domain complexity with accidental complexity. We can't avoid complexity in the systems that we build, but we can choose how to implement it. And the way that I think about it is that monoliths are inherently, this is a generalization, but I think that they are a simple arrangement of complex things. It's one thing, right? You take it up and you deploy it, but they have, all of these things that interconnect and big models and all of those sort of things. Event sourcing with CQRS, on the other hand, I would consider a complex arrangement of simple things. Each reactor, each projector, everything, each command handler, etc., are inherently very simple, but the complexity comes in the arrangement of them. Same goes for microservices, by the way. Don't listen to people who tells you that microservices make things simpler without also acknowledging that it makes things harder in other ways. Event sourcing with CQRS in this style of architecture has a lot of moving parts. It's got difficulty tracing across asynchronous components. And what you really want to be on the lookout for is when it devolves into a complex arrangement of complex things. And you have, monoliths that can devolve into a complex arrangement of complex things as well. But this is something that I see a lot of because we have developers who are used to working on monoliths. And so what they're used to doing is building complex things. And now they also have a complex arrangement on top of that. It's easy for me, or from my experience, it's easy to get to the complex arrangement of complex things, which is kind of like the worst of all worlds, with a cognitive load simply that comes from having this fundamental paradigm shift. Most developers will struggle, and to be perfectly honest with you, this is the #1 problem that I've had in all the time that I've been doing event sourcing is not the technology or the systems or anything, it's the developers who write the code. Cultures of control, I think we're almost at the very end. This is more around how your business behaves. In some cases, it's not appropriate to allow systems that you have less control of to consume events. And sometimes, events contain all the data, and you might not want to or be allowed to share all of that depending on the culture of the company that you work in. I think event sourcing with CQRS favors environments where autonomy is a cultural norm rather than one of control. But you can do it in tighter control environments, in which case you'll find yourself keeping your event store behind high walls, building more standard APIs, and maybe even create event streams that have filtered data that you want your clients to be able to have. At the end of the day, I want to emphasize that this is a pattern. It's not appropriate for every use case. It's not a silver bullet. There are a lot of instances where I think it can really, really help, but there are some cases where it's also not going to work. It's got lots of awesome benefits, but also some significant disadvantages. If you can overcome some of these challenges, it can be very powerful and really help you out. But I want to kind of finish with a quote from a colleague of mine. He's a good friend. He said, "I've started to think of event sourcing as a multiplier. If you do it well, it gives you almost magical powers in terms of flexibility and scalability and lots of other benefits. But if you do it poorly, it becomes worse than even the crappiest bowl of mud." And I think there's something to this, because it's one of those. It's a power tool. If you don't do it well, you're gonna chop your hand off. But if you do it well, you can build the most amazing things with it. And with that, thank you very much for listening.
I think we have some time for some questions.
Could you ask quickly for a show of hands of who here is using event sourcing and who's willing to use it? Who's using it? Who's using it now? Okay. Who's willing to use it now after the talk? Okay. Yeah, that's
cool.
That's cool.
Maybe you already thought that beforehand, and I did nothing to change your mind, but I'd still consider it a win. Yes.
Yeah. Finally, I ask my question. In this model, if commands which rejected not end up as event.
Yes.
There is, I can imagine at least a couple of cases when I want record event, some rejected commands.
Yes. Absolutely.
Is it like mechanism for that
Yes.
in this model?
Yes. So we actually, I didn't want to go too much into detail of that. I wanted to kind of try to keep things relatively simple. But we actually have situations in our systems where we have a rejected command that also results in an event. That's not the norm, usually no, but we have particular commands around asking for access to things, for instance, and if that access request is denied, then that is a semantic fundamental business event as well that we want to be able to keep track of. So yes, there are absolutely going to be cases where you have a rejected event, a rejected command that results in an event.
Even in banking, when you reject, with the banking ATM example, when you reject it to withdraw money,
Absolutely.
you want it.
Absolutely. If somebody
recorded.
tries to withdraw money that they don't have, that seems to me like a good use case for, you might want to capture funds withdraw failed or similar events. So yes, it's absolutely the case that you might have that. I was generalizing.
Any other questions?
Super quick question on when you were talking about rebuilding the projections.
Yes.
Like every time you do a database deploy or deployment, isn't it? Do you go from the beginning? And I'm wondering if, like in a really big data use case, you run into a situation where you may never catch up before your next deployment.
So we don't rebuild on deploys. It's more a case if you want to change a projection in any particular way. So let's say that you have you want to add another column to a projection. In that case, you spin up a second projector that populates a second projection, while the existing projection keeps where it was at and it keeps running. And all of your reads from clients go to the first existing projection until a point where you feel satisfied, and that's your choice, where you feel satisfied that the new projection is good, and you can even eyeball it, right? You can spin up a new projection, let it run for a little bit, eyeball it and see, does this make sense? Does it look right? No, okay, throw that away, try again. Meanwhile, all your reads keep going to the initial projection, and then only when you feel comfortable can you switch to the new projection. So that's effectively how you deploy a change to a projection. But if that doesn't happen on deploy, that's a change that says, okay, now we want to build a new projection.
Last question.
Hi, I was curious about the distinction between reactors and projectors and why you feel that's important. So, like, are there pitfalls, say if you were to have a projector that sometimes noticed particularly interesting things and put out events?
Sure. So I did say that I did have a slide that I kind of glossed over a little bit. I feel like projectors are a subtype of a reactor, which means that they behave similarly in many ways. A reactor, it can trigger external behavior, and you can call that external behavior populating a database table. The reason for why I make a big distinction between them is more around how they are deployed. With a reactor, for instance, you tend to only have one of them, and they are single-threaded by nature. And you don't want to have two reactors of the same type running at the same time, because if they do, they will both react to the same event and send two emails or whatever it might be. Projectors, on the other hand, are much safer, and you can have multiple projectors of the same type running in different clusters or different data centers that create different that maintain projections. So it gets more a case of you want to be careful around how you deploy reactors, whereas projectors are much safer to duplicate or have multiple instances of. Does that make sense? Cool.
Thank you very much, Conrad.